hello, hello. Am I audible? Um, this is supposed to be like a 90-minute thing, but the idea is to speedrun it. The core objective of doing this workshop is basically just explaining the grand vision of what we mean when we say chain abstraction, and then digging deeper into more technicalities about what are the different EIPs or ERCs across the stack that would help you accelerate or give the chain abstraction vision to your end users. One way how I describe chain abstraction is if you are an app developer, then removing the word chain, bridge, and gas from the user journey altogether is the final end state of how I see chain abstraction. And so if you're an app developer and the user does not see those three words anymore, they just go to your app, click a button, and get the execution they want, is the eventual end state that we imagine. As the MC already told, I want this workshop to be more interactive. Feel free to just stop me, raise your hand. We can have questions. We can have like a Q&A session. There are a bunch of ERCs that have their own like historical context and more technical depth. I won't go into like a lot of historical context and technical depth, but the core idea is just to explain like what it tries to achieve, and we won't get too much into the nuances, but like how it takes you closer to the desired end state is the objective of the workshop. Okay, so a few things. This is like the outline. The first thing is I just want to talk about the blockchain cake, or how we think like what are the different actors or different layers in the blockchain ecosystem. Then like what are the ERCs that interact on the permission layer? What are the ERCs that basically are required between the dApp and the permission layer? So permission layer is more like the wallet. So the dApp and the wallet layer, what are the ERCs that you need to basically communicate between these two entities? And then what are the ERCs that are needed to communicate between the permission layer and the solver layer, so like the mempool layer? And then what are the ERCs that you need to communicate between like the solver layer and the settlement layer? We'll get deeper into like what each of these terms mean, but this is just like the broader context. And so like the first section is just about explaining like what is the grand vision of what we are trying to do. This is something that I call the united block spaces of Ethereum. If you think about the last bull cycle, everything was amazing. Like you had the DeFi summer, you just went to an app, you clicked a button, you had the thing that you wanted, you went to Yam Finance, you clicked a button, you were able to deposit into these DeFi ecosystems, and everything was super smooth. The only thing was you were paying $100 for a transaction. And so after that, this roll-up centric roadmap, L2 centric roadmap sort of emerged, and it was a solution to this like block space is becoming costly problem, but it has created a fragmentation problem. And so the L2 centric roadmap has brought us many block spaces. Some block spaces are red in color, some block spaces are blue, but they all commit data to the Ethereum L1, but they don't feel like united. There's just too much fragmentation. If you just look at like the UX that you are giving to the user right now, you have three different types of Ethereum. If you open like your Coinbase wallet, you have three different types of Ethereum. It just causes a lot of friction to the user. Whenever you try to change your network, it just pops up and says, hey, do you want to switch your network? And then the user like has to go and then click another button. And even if you want to transfer funds from one chain to another, it's like you go to an aggregator and then you send those funds to some other location. You like have these different options where the user can choose between time and cost, and it's a very like buggy and frictiony experience for the end state, and this is why it does not feel like united block space. Like imagine if you're living in the United States and every state had its own version of US dollar, and you had to convert when you're moving to one state to another in its own version of US dollar, then it won't be as as smooth a UX, or when you were moving from one state to another and you had to basically get a visa stamp whenever you move from one state to another, it would not have been as united. And so this, like, if you solve these problems, then the Ethereum ecosystem, the whole EVM ecosystem will feel united again. And so that is, I think, the final vision of what chain abstraction is all about. A little bit detour to just explain what we mean by the blockchain cake. And so we imagine like blockchain has different layers, and there are different parties who are operating at different parts of the stack, but they own, all these parties fall in like 4 broad categories, and they have their own sort of trade-offs that they are trying to optimize for. The first is like the application layer or the dApp layer. These are things like Uniswap or Aave. A user goes there. This is like a UX interface in front of the UX, in front of the user, and then the user goes there, clicks a button, gets the thing that they want. The main thing that application layer does is basically generate call data for the user. So the user goes to the website, clicks a button, it generates the call data that needs to be, or generates some sort of instruction that needs to be executed, signed by the permission layer, and then executed on the blockchain. So the thing that application layer really tries to optimize for is finding the application that the user wants and then reducing as much friction as possible. Then there is a permission layer, which are things like wallets. And so there are multiple parties who are doing different things in the permission layer, but at the end of the day, what they're trying to do is convert this instruction that is coming from the application layer into some sort of signed instruction that the blockchain understands and is able to execute and change state. And so the application layer is constructing some instruction format, and then the permission layer is basically converting that into a language that blockchain understands. So it can be a transaction, it can be an intent, and then it gets executed on chain. And then the solver layer is basically all your mempools. So in V0, you had mempools, and then as the MEV problem evolved, you had like more sophistication that developed on the solver layer. But at the end of the day, it's all about the step between signing and finality. Everything that happens to your transaction between signing and finality is what the solver layer cares about. It cares about liquidity, it cares about sequencing, it cares about all the different types of auctions you have. There are maybe 100 different companies who are just operating on the solver layer, but this is like the core trade-off that the solver layer tries to optimize. And then finally, the settlement layer, these are your blockchains and oracles where things get finalized, and then that becomes your root of trust. Maybe just like just as a warm-up, as a show of hands, can people just raise your hands? Who is working on the application layer in the audience? Wow, quite a few people. I did not expect so many. There's this joke running. There's a running joke in crypto Twitter, which is no one is working on the apps. Everyone is working on the infra. And then there's the permission layer. Like, who is working on the permission layer, like the wallets and policies and intents. A nice, good set of audience over there as well. Who's working on the solvers? Quite a few people. And then settlement layer, like chains, oracles. Nice. A little bit less settlement layer people. Maybe they don't like chain abstraction that much, but it's fine. Okay, so let's look at the core trade-offs that each of these layers are trying to optimize for, and basically what decisions these players in these layers of the cake make. You get like different properties of your application. And so the core trade-off that the permission layer is trying to decide on is between UX and user agency. And so like you have one set of users who just use like hardware wallets, who verify the transaction hash, that if the transaction hash that they're actually signing on the hardware wallet matches the thing that they see on MetaMask or some other wallet. And at the other end of the spectrum, you have people who just use Telegram bots and they just send their private keys to a backend server. And so, but Telegram bots still generate like 20-30% of the volume. And so there is this trade-off between what great UX you want to give to the end user versus how much agency the user wants for them. And this is like a trade-off that app developers or dApp developers or wallet developers actually have to care about, and they lie somewhere or the other on the spectrum. Another interesting thing that has sort of emerged is like, if you guys have used these apps or dApps which use Google SSO, all the Google SSO verification or authentication that happens cannot happen on-chain. It happens in some off-chain compute system. And so what the app that is doing Google SSO is doing is it checks if the OAuth token that Google has given you actually corresponds to the private key that they store in some secure enclave or secure environment, and then sign it. And so even apps that are providing you Google SSO are making this UX versus agency trade-off, where users who actually ask for Google SSO are letting go their agency, letting go of their censorship-resistant properties for a much better UX. And so it was very interesting for me to see like the rise of these apps which like let go some parts of the decentralization or the censorship resistance aspect for this improved UX. And it's coming from like a user demand. The second thing the second layer, basically the solver layer, optimizes or trades off between finding the optimal route versus giving you like an execution guarantee. And so if you imagine a world where there are multiple chains, a user is holding balances in 3 different chains, and says, I want, like a user is holding $100 on 3 different chains and says, I want $100 at the end of the day on chain 4, find me the best route, pull the funds, give me the liquidity. There is this trade-off on the solver layer between like, what is the best price that you can give to the user versus can you actually execute the transaction or not? And so that's the trade-off that the solver layer sort of struggles with. And finally, on the settlement layer, there is this trade-off between fees and execution speed. So like if you are trying to move messages across 2 different chains, there are different ways in which you can pass messages. Like you can either rely on the L1, L2 bridge, which has like 7-day delay, but that is like the most secure way of transferring funds. Or you can trust like some other bridge provider which has a multi-sig and it will give you just things instantaneously. And so there is this trade-off over there. There are some properties that obviously we don't like, but there's a breadth of options available, and that's what the settlement layer sort of struggles between basically giving you a better execution speed versus like the cost of time or cost of doing that execution. Any questions till now? This was a little bit heavy or not heavy. Any questions till now? No? Either I'm very good at it or no one is listening. But okay. So this is what I imagine the expected end state to be from a perspective of a dApp. So if like you're a dApp developer, this is what the end state of chain abstraction I think looks like, which is a user comes to your front end, a user comes to your dApp. They don't see these 3 words anymore. They don't see the words gas, chain, and bridge anymore. It's just abstracted away from their experience. The dApp basically is deployed on some chain. It's deployed on some settlement environment, L1, L2, L3, whatever is their prefers, be it ZK, be it EVM, be it maybe even the new versions of VMs that are popping up. The dApp is deployed over there. The dApp requests either the wallet or the solver layer, what is the effective balance of the user on this particular domain, on this particular environment. And then knowing that effective balance of the user on that environment can generate the call data that needs to be executed on the environment. And so all the process of basically pulling the funds from multiple domains into the target domain, into the target chain, is responsibility of everything downstream. So like the permission layer, the solver layer, the settlement layer, the dApp, the only thing that the dApp cares about is what is the effective balance of my user over here, and then what call data I should generate, or what intent or whatever is the format I should generate to basically execute this. And so like users can hold funds, like if we get back to this united block spaces of Ethereum vision, then users can hold funds on these multiple domains at the same time. Like they can hold $10 on mainnet, $50 on Optimism, $30 or $40 on Arbitrum, and then the wallet or the solver figures out how to pull everything over from all these 3 domains and executes the call data on base. Maybe the user wants to buy some meme coin on base. User just clicks a button, gets the execution, and that's what the dApp and the user cares about. Any questions on the vision? Any challenges? Things people don't like? I'm getting good at sales apparently. So, okay. So let's take a step back. Let's only look at. So in my opinion, you need ERCs at these different interface points between different layers, and those are the things that we should sort of standardize. There are some like ERCs that I think are interesting on the permission layer, which give interesting permissioning or interesting properties to the apps. And so we'll take a little bit detour. We'll just look at the permission layer ERCs and then go deeper. Okay, so first ERC is 4337. So when Ethereum launched many years ago, I don't remember. Maybe Dror knows, but when Ethereum launched, everyone had EOA wallets. So like, and your wallet basically is responsible for doing three things. It is responsible for giving you some sort of an on-chain identity. So like your private key, when it is converted into some sort of a hash, gives you an on-chain identity. Your wallet is responsible for signing, which is basically verifying if the thing that you are saying you want to do is actually coming from you. So it does auth. And then your EOA wallet is also responsible for basically constructing this instruction set to the blockchain. Over time, people sort of figured out that this is very like restrictive, and this does not have the proper properties you want for a very good UX. The thing that was limiting, there are a bunch of things that were limiting with something like this. Like one thing is you cannot have modifiable authentication. And so like if you want to do something like a multi-sig, then you would need to deploy a new smart contract on chain, which has its own sort of authentication mechanisms. People also call them policies. So you can have more fine-grained policies, like this app can only withdraw these many funds, or I can only execute $1,000 worth of transactions in the next 24 hours, stuff like that. So all that is doable on chain. All those like checks and balances are doable on chain. And then another property that basically dApp developers wanted was batching of transactions together. Basically, like the Flashbots API just does this, like ensures batching of transactions, and so like you have a big entity just formed to enable that property to the transaction layer. And then also because you can do batching, you can do like gas sponsorship, so that you can give the user $100 in ETH, let them do the transaction, and then withdraw $100 of any other token in your solver. And so like these two properties is what people wanted from a modern account, which is granular authentication and ability to basically execute transaction on behalf of the user. So like gas abstraction is also what people call it. And so 4337 gives you that property. I won't get into like all the details of what are the different types of instructions you can pass or enable, but yeah, these are the two properties. One thing that I think is pretty nice is 4337 is gaining momentum and gaining adoption, and so it will be like the default way how people deploy smart contract accounts on chain. But for a cross-chain setting, how 4337 is also important is if you are on some target chain and you want to execute a transaction on behalf of the user, but the user does not have any funds on the target chain, this message.sender property is very important for every dApp. So basically the way dApp authenticates if a request is actually coming from the user, it is by verifying if message.sender is the user or not. But if the user does not have any funds on the target chain, like the user cannot execute the transaction. And so how 4337 helps is if your user has a 4337 account, or if your user has this batching property, which will be possible with 7702 whenever the 7702 hard fork comes as well, The solver can just fund the user with the money that they want on the target chain and execute the transaction on their behalf. The user does not have to basically, the user does not need to be responsible for executing the transaction itself. And so it has many other interesting properties as well, such as DOS resistance. So like you always have a mempool which is decentralized, where transactions, you can just leave transactions and they will eventually be executed on chain. But I think from a point of view of the chain abstraction vision, this message.sender property is a pretty interesting one. The second one, which is like, we are still in the permission layer, we are still in how, like what are the properties that you give to your account, basically. Over time, people sort of figured out that we cannot create new accounts with new properties every time we want to do something new. We wanted some way of basically installing programs into your account. So similar to how if you have like a phone or if you have your laptop, you install applications into these hardware devices, you can basically install modules into your account and get properties. Like another clean thing about this modular smart contract design is someone can just basically create one module, make it public, get it audited, and everyone in the ecosystem can basically just install it and get those properties. Any questions till now? No. So like the three main modules that are available. One is the validator module, where you can basically install, these validator modules, and the only thing that the validator module does is basically checks things before an execution happens. The second thing is the execution module, which actually changes state on chain. And then there are pre and post hooks where you can do some conditioning before and after an execution module. There are two different versions of it, like one is gaining more momentum compared to other, but both try to solve the same problem, which is how do you create this communication layer between an account and installable functions. The second type of ERCs are on permissioning. So imagine you have your Google account and you are able to permission applications. So whenever you connect your Google account via SSO, let's talk only about Web 2 world. Like whenever you connect your Google account via SSO to another application, you are basically giving them permissions to do something with your Google account. Permissioning standards or permissioning ERCs are similar like that, where you can basically give permissions of your account to some other application. And so there are quite a few applications already that are live, which sort of give session keys to the application. So if anyone has used Hyperliquid, then the thing that they do is you go over there, they attach some session key, maybe I think in the browser context or in their backend. And so you just sign once when you log in. And after that, you don't sign anything. You just click a button and the session key behind that, who is responsible for executing or generating call data and making sure everything is valid, executes or generates the call data and signs stuff for you. So there's no MetaMask pop-up. Like the only time there's a MetaMask pop-up is when you log in, and after that there's a session key that gets attached to the dApp, and then everything happens either on the browser or on the backend. I'm not exactly sure. So there are these two ERCs that handle that. I don't know which one will gain momentum over time, but yeah, there's this. These are in flux. The good thing that these also touch upon this UX versus agency trade-off that I talked about earlier on the permissioning layer. So like, if you don't want the user to be troubled by like a new pop-up every time you want them to do something, you can add a session key to their account, and then it will be just like a click of a button. And you can generate multiple signatures or multiple transactions just because they have clicked something once. There is another one which I sort of like, which is Merkleized signatures. It is not a standard yet, but so imagine a world where, again, let's take the example where you have funds on 3 different chains and you want to get the funds on some target chain. The thing that you will have to do is basically sign 4 transactions. withdrawing funds from those 3 different chains and executing the call data on the 4th chain. If you have something like Merkleized transactions, then you just sign once. Like your MetaMask just pops up once, and all those 4 transactions are in some sort of a hashed format, and you just sign once, and it's like a one-click signature experience. That signature is valid across all the 4 domains, but it will only be executed at the particular chain ID that it has instruction on. So you can really give the user this one-click experience without making 4 different pop-ups every time for every different domain. Okay, so that was all about permission layer ERCs. Let's look at like the interface between the dApp and the permission layer. Any questions till now? Yes. Yeah, it's not. I think it's on Biconomy docs. It's not. Yeah, it's not. There's no ERC for it, but it's just something that I like, so that because like you can using that you can basically do one click, sign 4 different transactions. All those 4 different transactions are just valid on their particular domains. And so you carry that information on chain, but the execution only happens for that particular chain ID. So in the permission layer, like just to recap, on the permission layer context, we looked at 4 different types of ERCs that are in flux that will smoothen this UX versus agency trade-off. One is on 4337, it gives you this message.sender property so that the user does not need to have funds, the user does not need to execute the transaction on the target chain. The solver or some other third party or even the dApp can do it for them. The second is how do you modularize, how you add more properties to your account. And once you unlock that, you can add like session keys, you can add these Merkleized signature type things, and you don't even need to write any of these anymore. Like people have written these smart contracts and got them audited, and you just need to install them in your account if it follows the standard. Okay, let's look at how the dApp should communicate with the permission layer. So this is another thing which is in flux. There's no ERC for it yet, but one end state, if you want to have like the united block spaces of Ethereum, is you need like the transfer should the bridge should be as easy as a transfer. So right now, it's like a very, very buggy experience. I just showed you how like when a user is trying to move funds from one domain to another, they have 50 different options and they need to choose between speed and cost. But one thing that you can do, and it's still, I don't know the exact specifics where it will land, but at the end of the day, this is what an address will look like. So it will have your normal address hash and then some information of the chain. And then every chain would have to register some sort of an ENS domain. That domain will have all the metadata that you need, that the wallet would need to basically unfurl where I should send the funds. And that is how you would be basically like pasting the desired address of the user. The other thing that app needs to do is even just figure out what is the user address. In cases where you have smart contract accounts or different types of authentication mechanisms, it is not very easy to figure out what is the address of the user. And so this is one way in which the dApp can communicate to the wallet saying, hey, just give me the smart contract address. Sometimes even the user might have different addresses on different chain IDs. And this is one way to basically request what are the available addresses for the user on all different chain IDs, and then construct the call data according to that. Another interesting thing that is happening between this dApp and permission layer is there are these session scoped EIPs or ERCs that are being formed, which is the dApp can maintain a session with the wallet and only request certain scoped properties. So it can maybe only request I can read your balances, it can only request I can execute some transaction, it can only request I can change some properties on certain chain IDs. And so similar to how you have whenever you basically authenticate whenever you log in via Google SSO or Facebook SSO, you define some scope properties that these apps can unlock. There are these four CAIPs is what people call like chain agnostic IPs that give these session properties. So you can either create a session, revoke a session, change a session, or even like if there is a session that is active, just get a session. Very similar to how like a dApp in the Web2 world will interact with your Google or Facebook backend servers. Another interesting ERC or EIP is this one called batched calls or batch transactions. So it creates, so suppose in a multi-chain world or a multi-chain world, what you would want is to execute something on the target chain. You might want 4 different things to happen one after the other. Either 4 different user operations, 4 different transactions, and this is the way how dApp can tell to the wallet that, hey, I want these 4 or 5 different transactions. Can you execute them in batch? And instead of just sending one particular transaction, waiting for execution and then sending the another one, you can just send a batch of transactions to your wallet. And if it is a smart contract wallet, the wallet can execute it in the same transaction. It will execute those user ops. Or even if it is you can even send instructions to execute multiple user ops or multiple transactions on different chains. And so this is how you do like batched transactions in between dApp and wallet. Another interesting property it has is this get capabilities feature. So a lot of the stuff that is driving these sort of some of these ERCs between the dApp and the permission layer is the idea that you should have smart wallets but dumb apps. So the app should only care about what call data I need to execute, what is the slick UX that the user wants, but the wallet should care about all the other intricacies of how I need to bring the amount or how do I need to bring the assets to the final destination. This one is a combination of the scope and the call that you want to execute. Another interesting one is, so right now dApps need to basically get a list, have a sense of what assets the user has, and then query them with their node provider. So like, okay, does the user have USDC? Does the user have this? Does the user have that? And then just query them. This basically gives the responsibility to the wallet. And so dApp can just basically query, okay, for this address, what are the assets? Can you just give me all the assets? Or can you give me these assets and these balances? And so all that job that the dApp was doing to basically fetch balances is offloaded to the wallet, and only the wallet is doing that job. I think this is like, because a lot of this work is repeated across both dApps and wallets, I think this is a pretty powerful ERC. Yeah? I'm not sure. I think only ERC20 for now. I can get back to you, but I think only ERC20 for now. Any other questions? No. Yes. Yes. Can you use the?
Mentioned that we already have an execute batch function, right? In the ERC 43337. Is it using EIP 5792 behind it?
So in 4337, you can execute user ops one after the other in the same transaction. 4337, so it gives your account that property that it can execute these things in the same transaction. 5792 is only about between the dApp and wallet saying, I want these things to happen. And then the wallet needs to figure out if it is a 4337 account, then it can do it in the same transaction. Or if it is an EOA account, then it needs to do it one after the other. And so.
And what about like cross chains? Like if I have, let's say, for example, gas fee, I don't have a fund on a particular chain.
Yes.
But I want to do some transactions, then how do we have to separately communicate between different chains for this?
Even that is like the wallet's responsibility. The dApp just says, these are the things you need to execute, please execute them. There is also like a flag where you can specify if these things can happen in parallel or they need to happen sequentially. And so that is how you can do some of the cross-chain
Thank
stuff.
you.
The next set of ERCs are between the permission layer and the solver layer. So how does your wallet communicate to the mempool layer or the solver layer that please do this? So the wallet has converted the instruction that is coming from the dApp into some sort of signed message that the blockchain should understand. It can be like a intent, or it can be a user op, it can be a transaction, like an EOA transaction. But yeah, like by this point, at the end of the permission layer, the wallet has signed something for you. One way I think the distinction between applications and wallets is applications generate the call data or instruction, and then wallets are responsible to sign them and convert them into a language that the blockchain can understand. Yeah, so one thing which is sort of popping up is this intent framework. Let me just take a sip of water. Any questions in between? Cool. So when you are trying to communicate between two chains, you can either send tokens, transfer balances, or you can basically send information or send messages across. And if you look at the things that an account has, it either has balances, so things that are fungible, assets or things that are fungible, and then it has some sort of like authentication scopes that are attached to it, like a multi-sig address or a session key or some other property or a policy. And so when you are in a cross-chain world, when you are in a world where there are different domains, you need to sort of sync up the authentication scope all the time, but maybe send the balances at execution time. Do you have a question? No, okay. So this one is about moving assets across chain. One interesting property when you're trying to move assets across chain is because assets are fungible, you can basically pay a solver or pay a sophisticated third party to just move those assets instantaneously. And so this is why you have these solver or intent type of frameworks that have emerged, where you have a sophisticated third party who takes some money and gives you this speedy execution. But when you're trying to move messages around, you cannot have loss. It cannot be lossy. When you're trying to move messages around and you're trying to basically maybe vote yes in a governance vote, you cannot vote a maybe. It has to be a yes. And so when you're trying to move assets, there can be some loss associated with it if the users are happy with it. But when you're trying to move messages, it has to use the most secure pathway to move it around. And so this is just a standard to move assets around. And this is, you can think of it as like a cross-chain limit order, saying I want to give these assets on the input side. Can you just give me this asset on the output side? And then it's the responsibility of the solver network to figure out which solver to use, what fees to charge, all the minute details. But this is how the wallet can communicate with the solver layer about can you move these assets for me and get me these assets at the target chain. There's another thing that we have been working on, which are resource locks. And so if you think about a cross-chain transaction, there are three things that happen in a cross-chain transaction. One is you need to send a message on the origin chain. Then the second step is someone on the origin chain or someone on the target chain is waiting for finality. So you send a message or send a transaction on the origin chain, either to a bridge contract, either to a solver network, and someone on the other side, on the target chain, is just waiting for finality or waiting for inclusion on this first message. And once they are happy that they will get the money, they can execute the transaction. And so this is like this three-step process, very synchronous, 1, 2, and 3, that happens, which causes this like long delay in in moving things around. And this is also how like centralized exchanges work. Basically, you send money to their escrow, they wait for a certain number of blocks, and then they debit you the money. This is what you need to do to basically guarantee equivocation protection between two databases. We are working on this thing called resource locks, where you can convert the synchronous process into asynchronous process. And so if you are able to come and tell to the solver layer by whatever means, you can attach this lock on an account level, you can attach this lock on a token level. If you are able to communicate to the solver layer that you will eventually get paid, don't worry about it, just pay the user right now, you can convert this 3-step process into like a very quick, like instantaneous process for the user. And that's how you are able to move assets instantaneously across chains. It has like an initial bump of actually users depositing funds into a lock, but once this lock is enabled, you can get instantaneous execution. I can show you a demo of how this works. So the idea is that you should be able to move funds cross-chain faster than you can move the funds on the same chain even. And so that is hopefully this demo works. Whenever I really want to make it work, it does not work. But just to give you like a recap, this is like the wrapper contract where users, so similar to how you have wrapped ETH, you can have a wrapper version of the contract where users just deposit funds. And similar to how when you deposit into WETH, you can use it on all the different dApps like Uniswap or Aave. Something similar, when you deposit into this wrapper contract, you can instantaneously move these funds across any domain. So this is a wrapper contract, and this is my address on Arbitrum. Let's just move. So I have already wrapped some funds. Let's just move a small amount of money, and what will happen is it will pop up like a simple permit to signature message that I just need to sign. And as soon as I've signed, I have basically sending to the solver the transaction. So I moved money from mainnet to Arbitrum, and it took like 2.9 seconds. And if I just if you look, the transaction on the mainnet is still pending, but the transaction on Arbitrum has already happened. I already got the money, and this is happening because you can do this like asynchronous communication between two chains. And you basically get this, if you unlock something like this, you basically get the speeds of Solana across the whole EVM block space. This is live, anyone can use it, just test it out. But you can, yeah. There's no ERC yet. There's no ERC yet. It's just.
So how did you do?
We did not, we are writing an ERC, but it's just like a quick demo. The contracts are public. It's like a wrapper contract, which just, so the main question is, can the user revoke this transaction or not? If the user can revoke this transaction, then the user has double spent and the solver has not received the money that they paid instantaneously. The way this works is when the user deposits into this account or into this token, they are voluntarily opting into a time-locked withdrawal. So they can withdraw these funds permissionlessly only after some time lock period. But
it's still pending, so it's not really
think it is
time
finalized. It
locked.
should be finalized by now. Yeah, it's finalized now. So the solver has received the money.
But like when you say 2 seconds, that's even less than the source chain confirmation time?
Yes.
And who are the party? Like, can anyone do it permissionlessly, or do you have some?
So right now
assumption?
it's in a permission setting. Like Peter from Relay is sitting over there who's doing it. He was waiting for the money. He was waiting for the money, but he paid it up front. But eventually, like you can also encode it permissionlessly.
But you can. You just said you can cancel, right? Like because it's
you cannot cancel.
You cannot cancel.
You cannot cancel.
Even though it's pending.
Yes, because you have locked the funds with that account or with that token contract, and the only way you can cancel it is if you unwrap those funds.
And the relayer is account.
Sorry?
Who put the money?
The user.
locked
The user voluntarily put the money into
before this happened.
Yes.
So before user put some amount of ETH, then they put the bridge instruction.
So let me take a step back. So over here, if you think about what is happening, at transaction time, user is paying this cost of finality or inclusion. But with the resource lock, the user, because by the act of depositing, has already paid that cost initially.
When did the person do it?
So whenever the user deposits, we wait for certain number of times to save ourselves for reorgs, and then we can say that there's no risk to the solver if the user will, you will eventually get the fund.
But what happened to the brand new user who just want to bridge something from A to 1? It sounds like you have to do some setup job to pre-allocate the one.
Yes.
So that when people do next time, it's faster. But if it's a fast time experience,
it is not.
Okay.
Yeah. So yeah, you need to top it up initially, and only then you get the speed. Otherwise, you don't get the speed bump. There's another question at the back.
Oh, I was going to say, can you talk a little bit about capital efficiency?
Okay.
And like the reality is, you've got to lock up the assets first. Are you planning to put it, the methods that you need into, say, wrapped ETH or something else, so that you don't have to hold, one balance ETH or staked ETH, that kind of thing? Yeah,
that's a good question. So there are different places where you can put the lock. You can have a lock in this in a module. So we looked at some of the valid ERCs where you can put a lock, where you can code different things in the module itself. So you can either put the lock on your account level, and so whenever you receive the funds are logged itself after some time, or you can put it on a token, and so whenever you wrap it, you basically lock them. But yeah, there is this initial friction, and so if the user has not logged it, it will go through this path. If the user has logged it, it will go through this path. Yes. First there and then.
Thank you. So this sort of lock is similar to how Gnosis Pay works in a way, so that if I as a user want to move money out, I have to wait a certain time before. So it's a 2 times transaction. I say I want to do that, and then I can move money out?
Yeah. So there are other things that also, if you look at this, there's not something new. This has been tried before by different people. They've just not named it. But there was Gnosis Pay who was doing it. So when you need to do something like this when you need to put a card on your on-chain balance, because Visa or MasterCard wants instantaneous guarantee, but on-chain it might take some time, or it might also be reorged. And so you need to put some locks in your account level. So Gnosis has put some locks on the account level to enable their card feature. I'm sure any other wallet who has their own card needs to put something like this, because Visa and MasterCard won't wait for 12 seconds or some finality guarantees. There's also this thing by Coinbase called Magic Spend, where you have funds in your Coinbase centralized exchange, and you want to execute them or use them on chain at transaction time. They have a lock as well. The lock is on the centralized database. So wherever is the source chain, you need to have some to get the snappy 3 second. And it took 3 seconds because it's a demo. Our indexers are slow, but ideally you should just sign the message, and it should take the time of the target chain. The target chain block time is the only thing that should determine. Any questions? Yes.
Yeah. Do you provide the source code on GitHub so we can dig a little more in the one if example?
It's not. I will make it public, but the code is there in the code is open source, so you can just.
So the smart contract, but I assume on the UI there is a bit of wrapping and off-chain packing, so I would like to read into it as well.
Got it. There is,
Maybe you have plans to publish it on your GitHub?
There are some docs. At the end of the slides, I'll share the link to the docs. But you can go to docs.onebalance.io, I think, and you should find all the docs.
Which docs? Okay, thanks a lot. Docs onebalance.io. Got it. Thank you.
Yes. So these are the documents. So you can just.
How do you handle reorgs on the source or destination chain?
So because the funds are logged, even if there's a reorg, you can just replay the transaction, and the solver will get the funds.
Can it cause a double spend in any way?
I don't think so, because like whoever is providing, there is some like entity that is, at the end of the day, what you're trying to do is solve for double spending, because you want the user to get the money first and then give the money to the bridge or the solver. And so effectively, whatever this thing is doing is solving for double spending. And the way this solves for double spending is make sure, okay, this transaction goes first, then this transaction goes first, then this transaction. Another way to look at it is it's like a account level sequencer or a token level sequencer, which is just trying to sequence transactions one after the other so that there's no double spend.
Yes, but you execute transaction on one chain and then on another. A reorg might invalidate one of them.
So the reorg might invalidate. So suppose a user signs a message, like a 712 message, send this much money to this address. First time transaction happens, then there's a reorg. Whoever is the paymaster can execute that transaction again and give the solver the money again. Because the funds are logged, because the resources are logged, the user cannot remove those funds. And so in the locking contract, you need to be sure that there is enough time that even if there's a reorg, the paymaster can replay the transaction. But yeah, so that is the only thing that you need to make sure. Otherwise, the solver will always get paid.
How much time is this locked?
I think in this demo it's 24 hours, but ideally it should be as long as you are sure that you can get the transaction included, even if there is some sort of censorship or reorg.
Thank you.
Yeah, more or less the same question. Sorry, I have to reiterate. So the input transaction, the user is supposed to submit the input transaction on the origin chain, right? But at the same time, you send it to the solver a signed raw transaction for the case that the input transaction on the origin chain gets reorged, so the solver can resubmit it anytime herself. But how do you deal with nonces, for example? You could invalidate the nonce with another transaction, and then it doesn't help that the funds are locked. You cannot use that signed transaction anymore. That's a good question. So at least on the token level, since it's just using permit to, the nonce are not sequential, and even on the account abstraction level in 4337, you can have parallel nonces. So. Got it. So you actually do not share the signed raw transaction. You share a signature, and the signature you can use in any transaction submitted by anyone, actually. Yeah, a user op or permit to are just signed signatures. Anyone can bring them on chain. Yeah, makes sense. Yeah. And ideally, it's in the best interest for the solver to bring the source chain transaction on chain, because they've already paid on the target chain, and even if there's a gas spike, they'll try to get as much money as they can. So even if there's a gas price, they'll keep on like bumping up the gas and make sure that they get the money that they paid for. Any other questions? Yes.
Are solvers permissionless, so anyone can become? Or
not yet.
Are solvers permissionless? Anyone can become a solver, or they've at least it somehow?
In the demo, not yet, but ideally, yeah, you can have a permissionless solver.
Okay.
Okay, so this was how you how like the wallet communicates with the solver layer to get some properties. Either how you transfer value or how you get this instantaneous cross-chain UX. Now once the solver has done their stuff, how do you validate, or how do you actually validate if something has happened on the target chain? So suppose in the case of 7683, the user has just signed a message saying, I want this much money. The solver pays the money, but how do you make sure that the solver actually gets paid? Or if the solver does not pay the user on the target chain, how do you make sure that the user gets back their funds? This is what you sort of try to do in between these two layers of the cake. There are two standards. One is just like a message passing. So if you guys remember, I told you like there are two types of messages or two types of things that you need to move across chain. One is tokens or fungible assets. And if you're moving tokens, the user can basically take a price cut, take some loss, and get this faster speed. Or you are trying to pass messages across. And so this is one standard to move messages across, like bytes. And then there is another one to actually burn and mint tokens across chains. So there are two different standards. One is by Optimism Superchain. I think the 7802 is by Optimism Superchain. And then 7281 is by a bunch of different like bridge providers. It was called XERC20 before. But the core concept is that a token can assign a bridge to become a burn and mint bridge, basically. So when we look at the solver type of a transfer between chains, there can be some loss. But in a burn and mint bridge, there is sort of no loss. You can just it's as good as a transfer. It's effectively, yeah. Even if you look at the code, it looks like it looks very much like how the ERC20 transfer is executed. And the token basically trusts a burn and mint bridge, saying that okay, verify or validate that the burn has happened. Just mint me the equivalent amount of tokens on the target chain. So very costless way of moving assets. That's all I have for you guys. This is some shameless publicity for what we do, but we have two different products. One is like the chain abstraction toolkit. So if you're a dApp and you want to just get all these properties of you just need to care about what is the effective balance on the target chain, and this is the call data I want to execute. Just make sure it happens. Then this is the product that you would want. And then on the second side, we have another product that we're working on, which is the resource locks as a service. So if you want this, one token is just one representation of it, but then there'll be more modules that we build on top of it. And so yeah, that's the other product. Thanks a lot. Any questions? There's one question over there at the back, or no more? None. Oh, there is one.
Just asking if you could upload the slides, because there was a lot. I got almost everything, but not all of them.
So where should I send it? Sorry.
Twitter?
I'll post it on Twitter. If I am Ankit Chiplunkar on Twitter and Telegram, feel free to DM me if you need anything.
Thank you.
There's another question somewhere there, right? Or no? Maybe not. Also, I can see that a few people did submit questions through Meerkat. The one that got an upvote was how to support Sol and BTC.
I think effectively it's the same thing. You just don't have like ERCs. There, at least the good thing about EVM ecosystem is you can have the same sort of language, but a lot of the stuff that we talked about will have to be changed a little bit for these ecosystems. But you can, at least from like a resource lock perspective, you can put a lock over there as well, and you can instantaneously move. You can even instantaneously move Bitcoin from just at a click of a button to another chain. But there's like a lot of other stuff that you need, all the different ERCs that we talked about, that need to be talked with these different ecosystems as well. And I don't know who is doing it. We are not doing it. I don't know if anyone else is doing it.
Another one is EIP 3370 already a standard for chain-specific addresses like base, 0x, ABC, blah, blah? What SafeX is using?
Yes, it is, but there's a different one. The main thing is like any chain can call itself base. And so how do you know what is the chain ID of the base? Any chain can have the same chain ID as well. And so with this chain specific address, like if you use ENS, then there is like a way to actually hoard that metadata on yourself. And the other thing with that proposed ERC is it will be permissionless, so a wallet can basically just run a light client and be able to get the metadata from that ENS ID.
Then we've got a question, how can a user ignore the chain? Aren't different chains with different security and performance properties?
There's a trade-off. Like some users won't ignore chains. Some users will be like, it happens right now as well. Like some users are like, I'll only hold Bitcoin. Some users are like, I'll only hold ETH. Some users want to trade meme coins. And this is just like a UX makeup on top of different properties that chains might have. Some users will care about it, some users won't care about it. And so if you are a dApp that wants to target the type of users that don't care about it, then use this. If you are a dApp that is very specific about, like the user should have all the context when they're trying to execute something like this, then the normal path is also available.
And the final question we have here is, how would wallets be deployed into different chains for initial setup?
There are different ways. So at least on deployment, I think one more interesting property that you get with 4337 is you get this deterministic address, and you don't need to deploy your account even when you're receiving funds on any chain. So you can just let the user receive the funds, and only when the user is trying to transact something that you can deploy the code of the account and then so it has these nice like Sybil resistant properties as well. That is one way. There's another thing that if the user changes their multisig on one chain, how do you sync up? It's a different rabbit hole in itself. There's keystore rollups, there are L1S load, there's a bunch of other things. We have not even touched about that over here, but yeah, that's a different rabbit hole altogether.
All right, that's all the questions we've got through Meerkat. Are there any final questions from the audience just spontaneously? Yes, can you wait for the mic so that everyone can hear you?
From the UX perspective, how long do you think it's going to take for us to be at a point where users and normies don't have to think about gas bridging and chains? Like, are we 2 years away, a year away, 5 years?
You can use these two apps. They are already in prod. There are a bunch of apps that are already in production. Users don't need to care about gas, chains, bridging, anything.
Okay. So
at the end of the slides, there are two apps that I link. They're just abstracted away. And if you're a dApp developer today who wants to get this like snappy UX, who wants to tap into all the different users who are on all the different domains, then you can use these things.
I guess the answer is the future is now.
Yeah.
Future was yesterday.
Cool. Thank you.
Lovely. Anyone else?